I ran short on time to get to these last two problems between 28 and 36. Let me just do 36 real quickly and then we'll get on to the new stuff. So 36, I'm supposed to find f minus g, leave the x alone or evaluate it at x. Make my parentheses with a minus sign between. In the first parentheses, put the right hand side of the f function. In the second parentheses, the right-hand side of the g function, emphasizing that x has an implied coefficient of 1. Simplify. First parentheses really wasn't necessary. There isn't a coefficient nor an exponent or a negative out front to make that parentheses necessary, so I'll just drop it. Second parentheses, attach the negative to the 1x, make it a negative 1x. Flip the sign on the negative 3, make it a positive 3. Combine like terms of negative 5x and negative 1x. Combine like terms of negative 3 and positive 3. Bring down the 2x squared. Negative 5x minus 1x is negative 6x. The 3's cancel. I'd live with that for an answer that has an obvious common factor of 2x that you should probably factor out. Both would be good answers. I like the factored one better. The next chunk of problems in the parentheses don't have an x, they have a number, and I made up some new functions. What am I supposed to do with this number? I'm not multiplying by that number, I'm changing the variable to that number. My answers for 37 through 48 are just going to be a number, and technically it's going to be a y and not an x. How am I going to do these? Let me just find the function that I'm supposed to change the x to negative 1. By finding h times k of x. H times k of x is just the h function times the k function, which is x squared plus 2x plus 1 times 2x minus 5. That's what h times k of x is. I don't want to simplify that, and I don't need to simplify that. What I need to simplify is h times k of negative 1, so I'm going to change my x's to negative 1. My answer is going to be the number that I get when I change those x's to a negative 1. I can use my calculator if I care to. I kind of care to right now. I don't care if all you did right now is just did first parentheses and then negative 1 squared plus 2 times negative 1 plus 1, close out my first parentheses, times 2 times negative 1 minus 5, close out my second parentheses. I forgot to sneak a parentheses in here. Let me get that left parentheses in. 2 times, I have to hit the insert key, but I don't have it going, so minus 5. Good enough. I think this is exactly what I have typed, handwritten. Looks good to me. Hit enter. My answer for 38, if I did this right, is going to be 0. Let me quickly do it by hand. First parentheses is going to be 1 minus 2 plus 1. Second parentheses is going to be negative 2 minus 5. First parentheses is going to be 0. Second parentheses is going to be negative 7. This comes out to 0 just fine. I have no problems with you just pressing buttons. I don't want you to go through trivial arithmetic in a college algebra class. So for 40, I'm doing k minus h evaluated at 0. I have to figure out what letters I'm going to change to 0 by finding k minus h of x. K minus h of x will have two parentheses with a minus sign between. The first parenthesis is going to have a 2x minus 5. The second parenthesis, an x squared plus 2x plus 1. Now I can find k minus h of 0, which is going to be 2 times 0 minus 5 minus 0 squared plus 2 times 0 plus 1. This whole thing comes out to minus 6. If you can do it in your head, do it in your head. Otherwise, do your calculator. First parentheses, 2 times 0 minus 5, and my first parentheses, minus second parentheses, 0 squared plus 2 times 0 plus 1, end the second parentheses. Answer, minus 6. If I want to put a letter to my answer, I could say y equals minus 6. Or I can write the whole problem and say k minus h evaluated at 0 equals minus 6. That's probably the best answer, but I'd probably likely just write the number negative 6 down. The x is actually 0, so it would be wrong to say x equals to negative 6. 42 wants me to do k times h of 4. Let me figure out where I'm going to plug that 4. I'm going to do k times h of x real quickly. To do k times h of x, 2 parentheses, no signs between implies multiplication. First parentheses, 2x minus 5, which is the k function. Second parentheses, x squared plus 2x plus 1, which is the h function. Now my k times h of 4 is going to be 2 times 4 minus 5 times 4 squared plus 2 times 4 plus 1. I'm going to get dangerous. First parentheses comes out to 3. Second parentheses comes out to 25. I think the answer to 42 is 75. And that's just dumb to commit that to video. Let me just see if I can do this. Parentheses 2 times 4 minus 5, close the parentheses, times 4 squared plus 2 times 4 plus 1, close that parentheses. Yeah, that's exactly 75. Next, you want composition of functions. No big deal. For 44, I'm going to find out what x's I need to plug in for 0 by finding h composed with k of x. To find any composition, I take the function that's written first and change its x's to the function that's written second. So I'm going to take the 2 h's in the h function, change them to 2x minus 5. And now I'm going to plug in 0. For my answer, I'm going to get 2 times 0 minus 5 squared plus 2 times 0 minus 5 plus 1. By hand, both parentheses come out to negative 5. So by hand, I'd get negative 5 squared plus 2 times negative 5 plus 1. Negative 5 squared is positive 25, plus 2 times negative 5 can be written as minus 10, plus 1. I think this whole thing comes out to 16. And to save a minute, I'm just going to pretend it's right. If it's wrong, it is what it is. I'll live with it, or you'll have to live with it. Maybe I'll have to redo this whole video to fix that, but let's hope that it's right. 46, let's do 45. 45, k composed with h of 3. Let me figure out what x's I need to plug in 3 to by finding k composed with h of x. By writing the function that's mentioned first without its x, and where the x is in the function that's written first, write the whole right-hand side of the function that's written second. So there's where my x's need to go. So I need to go 2 times 3 squared plus 2 times 3 plus 1, close out my parentheses, minus 5, 9, 15, 16, 32. This thing's 27 if I did it right. Quickly here. This is going to be 2 parentheses, 3 squared, plus 2 parentheses 3 plus 1, close out my parentheses, minus 5. Good enough. 47 and 48. 48, find k composed with h first. K composed with h of x first. To do that, I write the k function without its x. Replace that x with the function that's written second, which is the h. So replace that x with x squared plus 2x plus 1. Now change those x's to negative 6. think I can just backwards, second and enter, and change each of these 3's second insert to -6. Delete this 3. Back, 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 back. Second delete insert, -6. Delete that -3. If I've done this correctly, I believe the answer is 45. I tried to get lazy and not type the whole expression in. Looks good, so I'll pretend that that's right. 49 through 57, more of the same, just new functions. Let's do 49 because it's a division. For 49, it wants me to find s divided by t of 3. I need to know what x's to plug in 3 for, so I'll find s divided by t of x by forming a fraction that has the s in the numerator and the t in the denominator. So to do my problem, or your problem 49, s divided by t evaluated at 3 is going to be 3 squared plus 5 times 3 minus 3 over 2 times 3 minus 7. That's going to be what? 9, 24, 21 over -1. It's going to give me -21. On this calculator, I can do it slick. On my other calculator, I can't. On this calculator, to do this, if I hit my math button, arrow over to fraction, hit enter, I can go in the numerator, 3 squared plus 5 times 3 minus 3, move down to the denominator and do 2 times 3 minus 7, and get that -21. On my other calculator, I'd have to do this. I'd have to go parentheses for the numerator, and then 3 squared plus 5 times 3 minus 3, close off the parentheses for the numerator, hit my divide sign, parentheses for the denominator, 2 parentheses 3 minus 7, close my parentheses, and we get that same -21. I'll do 52 on this. 52, I want to find where I'm going to plug that 4 in, so I'm going to do s composed with t of x. I'm going to write the s function without the 2 x's that are in it. And in place of those x's, I'm going to write the function that's written second, or the right side of the function that's written second, which is the t function. And now I'm going to change the x's to 4. This parentheses comes out to 8 minus 7, which is 1. So this is going to be 1 squared. The next parentheses comes out to 1, so I'll get 5 times 1 minus 3. This is going to be 1 plus 6 minus 3. You can do this on your calculator. I'm doing this fast because that's just silly arithmetic. There's so many of these. I think I want to do one more and move on to the next concept. And of the one more, I don't know which one's harder. Let's do 57 together. T composed with s of -6. So first I'm going to find t composed with s evaluated at x by taking the t function that's written first, 2x minus 7, write it without the x. Where the x was, I'll put the right side of the function that's mentioned second, which is the s function. That's t composed with s of x, so now I know home for my -6's. Don't care to do that by hand. I could, but why? So this is going to be 2 times parentheses, -6 squared plus 5 parentheses, -6 minus 3, close my parentheses, minus 7. The answer, if I did this right and didn't press a button wrong, is going to be -1. If I press the button wrong, it is what it is. On a test, if you set the problem up correctly and then make a button pressing error, that's like a -1. Or if you do the math in your head and do it wrong, -1, not such a big deal. So try to knock out all of these. And then we're going to move to the monster part of this section, difference quotient. This is tremendously important. It is the beginning, the other part of what we do in this chapter that really ties tightly to the algebra and calculus. In the last section, we did average rate of change. Absolutely comes up in calculus. Difference quotient comes up as well. The difference quotient is this f of x plus h minus f of x over h. No way I understood this when I was a student. But I can figure this out if I know what the symbols mean. What I need to do to find a difference quotient is to replace each of the functions with... Whoa, my iPad just talked to me. She must have heard me thinking I wanted some music, which is cool. Anyways, I need to change those symbols to something more appropriate for the problem. For problem 58, I can change f of x to 2x plus 6 because it tells me that f of x is 2x plus 6. Ugh. It doesn't tell me what f of x plus h is in problem 58, but I need to change f of x plus h to something, so let me figure it out. F of x plus h for problem 58 is 2 times x plus h plus 6. To find f of x plus h, I just change the x to x plus h. So this is going to be 2 times x plus 2 times h plus 6. So the f of x plus h symbol, I'm going to change to 2x plus 2h plus 6. I'm going to leave the h alone because that doesn't have function notation. So this formula is called the difference quotient. If you took calculus, this is the beginnings of finding derivatives in calculus. So to find the difference quotient, I take the function that's given and fit the function pieces in the difference quotient to that function, tailor it perfectly. So for problem 58, the difference quotient is going to be f of x plus h, which is 2x plus 2h plus 6, minus f of x, which in this problem is 2x plus 6, all over h. All I need to do is simplify this, and it simplifies a bunch. In the numerator, first parentheses I can just drop without doing any changing. Second parentheses, I need to change the sign of both the 2x and the 6 to minus. That's going to give me 2x plus 2h minus 6 minus 2x minus 6 over h. 2x's cancel. This is a plus 6 right here. I wrote a sign error down. 6's cancel. This whole thing reduces to 2h over h. Now I can cancel the h's. The answer to problem 58 is just 2. That is really hard for students, and we're going to do a handful of these. Hopefully we can make it less hard because it's just plugging in, changing the functions to something that doesn't have function notation, and then doing algebra. So creating a non-function version of the difference quotient using the function that's provided and simplifying. 60, supposed to find the difference quotient, which is got to be given to me. This is a constant. What do I need to do? I need to change the f of x plus h to something that fits this problem. I need to change the f of x to something that fits this problem. In problem 60, the something that fits this problem for the f of x is 5x plus 4. The something that fits this problem for f of x plus h is what I get when I change the x to x plus h in the f function. And what that is 5x plus 5h plus 4, because I'm going to go 5 times x and 5 times h to figure out what my f of x plus h is. Kind of have the difference quotient right here. The difference quotient is going to be 5x plus 5h plus 4 in a parentheses minus 5x plus 4 in a parentheses divided by h. I changed each of the function symbols to what they're equal to. The function symbol to the right of the minus sign is always given. The function symbol to the left of the minus sign I need to figure out algebraically. Now I'm going to drop the first parentheses without doing any changing, change the signs to drop the second parentheses, and leave the denominator h. Now cancel the 5x, cancel the 4's and the negative 4's. These difference quotients always cancel a lot. The answer to problem 60 is just 5. '62 gives me something a little uglier, but not undoable. So for 62, I'm asked to find the difference quotient, f of x plus h minus f of x all over h. And I need to replace the f of x plus h and the f of x with stuff that fit the problem. F of x I can change to x squared minus 5. That's what the problem tells me f of x is. F of x plus h isn't given. I need to figure it out. F of x plus h is what you get when you change the x in the original problem to x plus h. Do this all the time in calculus, x plus h quantity squared. Super, super common to do. In fact, if you do it enough in calculus, if you take calculus, you're going to get memorized what this foils into. X plus h squared can be written as x plus h times x plus h. And if I FOIL this, I'll go x times x is x squared. X times h is plus x times h. I'm going to sneak a coefficient of 1 for the outers instead of writing just x times h. The inners are h times x, which I'm going to write as xh. Again, multiplication is commutative, so I can flip the order. Sneak a 1 there. My lasts are h times h, which is plus h squared. So in place of the f of x plus h, I'm going to write x squared plus 2xh plus h squared. Now I'm set. I know what to replace f of x plus h with because of the algebra I did. I know what to replace f of x with because that was given to me. So the difference quotient is going to be x squared plus 2xh plus h squared minus x squared minus 5, both terms in a parentheses in the numerator, all over the h. First parentheses in the numerator that I put really isn't necessary. If I didn't put it there, it wouldn't be wrong because it can just be dropped. Second parentheses, I need to distribute the minus through, make the positive x squared into negative x squared, make the negative 5 into positive 5. Get to my canceling. Both the x squareds cancel, and I forgot something. When I wrote this down here, I forgot this minus 5. This minus 5, I forgot. It needed to be here. Inside that parentheses, I needed a minus 5. So right there, I needed a minus 5. Right here, I need a minus 5. All I did here is I found x plus h squared, found it just fine, but I neglected the minus 5. And the numbers that don't have letters always cancel in these difference quotients. So this was a lapse of memory, or just being lazy. And this minus 5 and that plus 5 should have canceled. Only the pieces with the h's don't cancel immediately. So this difference quotient should be 2xh plus h squared over h. I'm going to factor out a common factor of h in the numerator and get 2x plus h. That's section 1.1 in intermediate algebra. Very important skill. And now I can cancel, and get an answer of 2x plus h. In a calculus class, you'll plug in 0 for h. Let's do 63 together because I kind of blew that one. Maybe pause the video and try 63. So for 63, in for the f of x plus h, I have to do some work. In for f of x, I know I'm going to put x squared plus 1. In for f of x plus h, it's going to be f of x plus h equals to x plus h squared plus 1. How horrible is that? F of x plus h, I change that x to an x plus h and get x plus h squared plus 1. Well, x plus h squared simplifies to be x squared plus 2xh plus h squared. So this guy right here comes out to be x squared plus 2xh plus h squared, and I still have the plus 1. So in place of f of x plus h, I'm going to write x squared plus 2xh plus h squared plus 1. So now I know how to doctor up my numerator. To the right of the minus sign, I take the given function. To the left of the minus sign, I take what I get when I change the x plus h in the x in the function to x plus h. So my difference quotient is going to be first parentheses x squared plus 2xh plus h squared plus 1 minus x squared plus 1 all over the h in the denominator. Now I'm going to drop the first parentheses, change the signs as I'm dropping the second parentheses, make it a minus x squared and a minus 1. Any term that doesn't have an h should cancel. The x squareds cancel, the 1's cancel, and this comes out to give me 2xh plus h squared over h. Numerator has a common factor of h, which allows me to factor it out and leave myself with a 2x plus h inside of parentheses. Cancel, cancel. The answer to problem 63 is 2x plus h. One more problem because we're butting up against 30 minutes and we'll stop. But these difference quotients are important. Let's do 65 together. I'll leave you 67, which is its twin. So for 65, were the f of x's in the numerator of the difference quotient, I'm going to put x squared plus 5x minus 3. Were the f of x plus h's in the numerator, I got to figure this out on 65. F of x plus h is going to be x plus h quantity squared, which I just figured out what that was a few problems ago, plus 5 times x plus h minus 3. I'm going to lift this and not do it by foiling. This is x squared plus 2xh plus h squared. This guy is plus 5x plus 5h, and I bring down the minus 3. So I foiled this, stealing it from my last page, distributed the 5 through there, and left the minus 3. So where the f of x plus h is in the numerator, I need x squared plus 2xh plus h squared plus 5x plus 5h minus 3. Surprisingly, no like terms there. The denominator stays h. So my difference quotient is going to be monstrous. The first guy right there, I would normally put in a parentheses, but I just wind up dropping the parentheses to save some time because I'm too long. I'm just going to drop the parentheses and write x squared plus 2xh plus h squared plus 5x plus 5h minus 3. And instead of writing the parentheses here and then writing a line with the parentheses change, let me drop the parentheses. I'll distribute the negative through, and change all the signs and get a negative x squared, change the sign of the positive 5x and get a negative 5x, change the sign on the negative 3 and get a positive 3, leave an h in the denominator. Any term that doesn't have an h should cancel. This x squared cancels with that negative x squared. This positive 5x cancels with that negative 5x. And this negative 3 cancels with that negative 3. So I'm only left with terms with h's. What I'm left with in the numerator after I do my canceling is 2xh plus h squared plus 5h. And the denominator is an h. The simplifying for these is generally just yanking out that common factor of h in the numerator and canceling the h in the denominator away. So I factored out the h in the numerator, left myself with 2x plus h plus 5. Cancel. I've canceled the entire denominator, so I don't need to write a fraction anymore. And what's left in the numerator is going to be my answer. Because I canceled out the factoring, I don't need a parentheses anymore. So my answer to problem 65 is that lovely answer. In a calculus class, you'd make it 2x plus 5 because you plug in 0 for h. There's one more difference quotient for you to do, and I'm not going to do another one just because the video is a little bit long, but it's the same idea. In problem 67, you're going to have to figure out what x plus h squared minus 5 times x plus h plus 8 is. And x plus h squared is always x squared plus 2xh plus h squared. That will come out every single time. And it's just something you could write on your note card if you get to use one of those. That's the hard part of 67. Then you get to take that and put it in the numerator of the, simplify it, put it in the left part of the numerator, put the f of x in the right side of the numerator, and do the algebra. Alrighty, let's pause. Definitely bring your calculator for the next section. It's going to be calculator heavy. If I could figure out again how to use my calculator for that section.